We've learned a lot so far about triangles and their angles and sides. Now, let's take a closer look at a specific type of triangle that has a ton of special characteristics. Here's a few hints. This triangle's favorite number is 90. Its strong, sturdy shape helps it hold up buildings. And with a little math, you can use any two sides to figure out the third. Any guesses? Recall that a right triangle is any triangle that has one angle that's exactly 90 degrees. How can we tell whether a triangle is a right triangle? We can look for the little square in the vertex of the angle. In a right triangle, the two sides that come together to form that right angle are called the legs. The side that's opposite the right angle, the one that doesn't touch it, is called the hypotenuse. Which side of this right triangle is the longest? Well, I remembered that the longest side is opposite the largest angle. Which angle is the largest in a right triangle? In a right triangle, the right angle is always the largest angle. That means the hypotenuse, the side that is across from the right angle, is the longest side.
Let's practice identifying the legs and hypotenuse of these triangles. Pause and determine which sides are legs and which side is the hypotenuse in these three triangles. Let's take a look at the first triangle. I determined that the sides with lengths 8 and 15 are the legs because they form the right angle in this triangle. Since those are the legs, then the last side must be the hypotenuse. I can also tell that this is the hypotenuse because it is opposite the right angle. In the next triangle, we can't see which sides form the right angle or which side is opposite the right angle, so how can we tell which sides are which? Well, we know that the longest side of a right triangle is always the hypotenuse. So 26 must be the length of the hypotenuse, and the other side lengths are legs. And in the last triangle, we know that the side opposite the right angle is the hypotenuse, and the other two sides form the right angle, so they are legs. Great work!
So, now we can identify the parts of a right triangle and determine which side is the longest. Like this triangle we just looked at, we know that this side length represented by the variable x is the longest side because it's across from the largest angle. But can we determine the exact value? That's where a special rule that is just for right triangles comes in, the Pythagorean theorem.
The Pythagorean theorem says that in a right triangle, and only in a right triangle, the lengths of the sides follow a special rule. The sum of the squares of the legs is equal to the square of the hypotenuse. You'll often hear this theorem in equation form, a squared plus b squared equals c squared, where a and b are the lengths of the legs and c is the length of the hypotenuse.
What do we use the Pythagorean theorem for? This equation connects all three sides of a right triangle. So if we know two of the sides, like the two legs or a leg and the hypotenuse, we can use that information to figure out the missing one. Let's try it out by going back to a triangle we already looked at.
We identified these sides as the legs and this side as the hypotenuse. Now that we know the Pythagorean theorem, we can use it to find this missing side length. In this triangle, 3 and 4 are the lengths of the legs, and x is the length of the hypotenuse. In the formula, a and b are the lengths of the legs, so we can substitute 3 and 4 there. C in the formula represents the length of the hypotenuse, which we don't know and is represented with the variable x. Does it matter which leg is A and which is B? It doesn't matter since those terms are being added together, and order doesn't matter when you're doing addition. Now we have an equation we can solve. If you're feeling confident, go ahead and pause to finish solving this problem. Otherwise, let's finish it up together. We can simplify the left side of the equal sign first. 3 squared is 9, and 4 squared is 16, and adding those gives me 25. Now we have the equation 25 equals x squared. We can use inverse operations to finish this up. What undoes the square? The square root. Taking the square root of both sides gives me the values of 5 and -5. But something to remember here is that these values are the side lengths of a triangle. Can we have a negative side length? No, so that means our only answer is +5, which is the length of the hypotenuse of this triangle.
Let's try another one. Now we have a right triangle where the hypotenuse is 13 units and one leg is 5 units. What's the length of the missing leg? So we have a right triangle with a missing side length. Sounds like we need the Pythagorean theorem. Let's plug what we know into the formula. We know that 5 is the length of one of the legs, so we can substitute 5 for A. We don't know the length of the other leg, so we can leave that as B. We also know that the hypotenuse is 13, so we can substitute that for C. Looking good! Pause now and finish solving this equation for B. Let's see how you did. First, I simplified a bit by squaring 5 to make 25 and 13 to make 169. Now to isolate the variable, I can subtract 25 on both sides, leaving us with b squared equals 144. Finally, we can take the square root of both sides. Since we're dealing with the side lengths of a triangle, we'll only use the positive results, which is 12. Great work so far! Let's wrap up with one last example.
I think you've got this one. Pause now and find the missing side length. To find the missing side length, we first need to figure out whether we are looking for the length of a leg or the length of the hypotenuse. We know that the side that is 10 units long is the hypotenuse because it's across from the right angle. That means that the other two sides, including the missing side, are legs. Substituting all of this information into the formula gives us the equation 8 squared plus y squared equals 10 squared. We can square 8 and 10, then subtract 64 on both sides. Now that we have the equation y squared equals 36, we can take the square root of both sides and find the missing side length is 6.
Today, we learned that right triangles have two legs and a hypotenuse. The legs touch the right angle, and the hypotenuse is across from it and is always the longest side. We also learned about the Pythagorean theorem and how to use it to find missing side lengths in a right triangle. When you finish these guided notes, you can move on to online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.